All right, hey guys, so I am going to present my screen and we're going to get started on lesson 6.6 day 1. In this lesson, we're going to be solving exponential and logarithmic equations. It's a 2-day lesson. Our goal today is to look at problems with the same base or getting the same base on both sides, logging both sides, dropping logs, changing forms. Okay, we have 6 problems to go through and I'll kind of give you some notes to go along with most of the problems. Oh, I forgot to open one more thing. Hold on one second. Okay. All right, so for the first problem, my notes for this are write in the same base if possible. All right. After you get them in the same base, you're going to use exponent, expo rules to write in terms of one base to one power. That's the goal. And then you'll be able to drop bases and solve. Okay. So for the first problem, when you have a fraction, I would recommend writing it as a number to the -1 exponent. So for this one, I'm going to write 81 to the x equals 9 to the -1 x plus 3. All right. And 9 and 81, well, I can rewrite 81 as 9 squared, right? So the goal is to get the same bases. And now I do. I have the same base of 9. I'm going to use my exponent rule. So I have a single base to a single exponent. So 9 to the 2x, right? Power of power, multiply the exponents together. Power of power on the other side, multiply the exponents together. So 9 to the -x minus 3. Once you have the same bases, you can drop the bases and just set the exponents equal to each other. So I have 2x is equal to -x minus 3. Now I just solve this linear equation. Add the x to both sides, so 3x is equal to -3. Divide by 3, x is equal to -1. Okay. For the second problem, all right, now it doesn't look like I can really go through the same process that I went through the last time because I can't get the same base, right? I could write 8 as 2 to the third, but I don't have the same base. So if you can't get the same base, what you're going to do is, so if you can't get same bases, you're going to do one of two things. You're either going to log both sides or you're going to change forms. Honestly, I would just change forms, but I'll show you log both sides as well. Okay. So this is going to be log both sides option. And over here, I'm going to do change forms. So you'll see 2 different ways of doing the same problem. All right, so log both sides. I'm going to write it as log of 3 to the x. So I'm just using base 10 equals log base 10 of 8. Now using my log properties, this exponent has to be written out front. So it's x times log of 3 equals log of 8. The goal is to solve for x, to get x alone. So divide both sides by log of 3. So now I have x is equal to log 8 divided by log 3. Now I'm going to pick up my calculator and evaluate that. Okay, so I have get a fraction. And it's just natural log, so I can just hit this button, log of 8 over log of 3. And I get approximately 1.89. So x is approximately 1.89. Okay. Over here, I'm in exponential form, right? It's 3 to the x equals 8. So I'm going to go from expo to log form. So it's base raised exponent equals an answer, BEA. I'm going to go to log bacon and egg. So log base 3 of 8 equals x. All right. Remember, the answer to a log problem is the exponent in exponential form. That's why when you change forms, you'll be able to get your answer. So now I'm going to take my calculator and just do log base 3 of 8. All right. So math, go down so you can get log base 3 of 8. And I should get the same decimal valuation, which I do. All right, so you have two different ways of doing that problem. In both cases, you get that x is approximately 1.89. Okay. For problem 3, my notes for this problem. So you're going to isolate the part of the problem that has the variable up in the exponent as much as possible. Okay, so first step is to isolate expo portion. And once you isolate the exponential portion, if base E, you're going to ln both sides, kind of like what I did in the last problem, log both sides. We're going to ln both sides. Or just like the last problem, you have another option, or change form. Again, for this one, I'd probably just change form, but I'll show you both. First step is to isolate. So I'm going to subtract the 9 from both sides. So you have 3 times e to the 4x equals 6. Then I'm going to divide both sides by 3. So still just normal inverse operations, isolating the exponential part. All right, now I'm stuck. I'm trying to solve for x, but x is stuck up in the exponent. So this is where you have your two options. You're either going to ln both sides or you're going to change forms. So I'll write ln both sides is going to be this option. And this way is going to be change forms. You're going to get the same answer both ways. So I'm going to do change forms first because it's faster. So this is expo form. You're in expo form. You're going to go to log form or natural log form. Doesn't make a difference. Base raised to an exponent equals the answer. I'm going to go log bacon and eggs, log base E of 2 equals 4x. The goal is to get x by itself, so divide both sides by 4. So x is going to equal log base E of 2 divided by 4. Now I'm going to pick up my calculator. Let me erase up here and pull my calculator up just a bit. All right, so I'm going to do fraction. And then I'm going to do math, log base E. I'm just going to type it in exactly as it is on my paper. Log base E of 2 divided by 4, enter. Okay, and you get approximately 0.17. So I think I ran out of room there. That's approximately 0.17. The other option is ln both sides. Okay, so if I take the ln of E raised to the 4x, it's equal to ln of 2. All right, so then there's a few different things you could do. Do you remember some of the tricks? If you have ln base E of E raised to the 4x, do you remember what that simplifies to? When the bases are the same, it simplifies to what's in the exponent. That was one of the simplifying tricks. So since ln has base E and the base is e, this side can just simplify down to 4x is equal to ln 2. We're trying to solve for x, to divide both sides by 4. So you have x is equal to ln 2 divided by 4. So I'm going to grab my calculator and I'm going to type in a fraction. So alpha y equals, get my fraction, and it's ln of 2 over 4. And you get the same decimal approximation as the other option. Okay. One thing I do want to point out, let me just see if I do ln 2 divided by 4, still get the same thing. But if I do ln 2 divided by 4, 4, 4, 4, come on, there we go. You are not going to get the same thing. So make sure, I prefer that you guys always just type it in your calculator exactly as it looks on your paper, because you're more likely to get the right answer. But remember, your calculator needs to be told to take ln 2 first, then divide by 4. So put that parenthesis behind the 2. So if you are not using a graphing calculator and you're using something else and you're getting the wrong answer, it might just be because of how you're plugging it in. So you might have to play around with that until you figure it out. All right. Or you can come ask me questions during 12th period. Okay. So that was number 3. All right. So for number 4, when solving log equations, there are usually 2 types, logs on both sides or log on only one side. So this is an example with logs, or ln in this case, on both sides. Okay. So when you have logs or ln on both sides, here are my notes. First, simplify each side to a single log. So you might have to condense if you can, but you want to simplify each side to a single log. Then you're going to drop the logs, just like we dropped the bases, but drop the logs and solve. And then finally, it's important for these problems to check. You can't log a negative. Can't log a negative. Okay, so check, make sure you're not logging a negative. Okay, so for this, since you have logs on both sides, you can drop the logs on both sides and just set 5x plus 2 equal to x plus 10. Okay, because if you have ln, then what you're logging needs to be the same in order for it to be equal. So subtract an x from both sides. So 4x plus 2 is equal to 10. Then subtract 2 from both sides. So 4x is equal to 8. Divide both sides by 4. X is equal to 2. All right. I'm going to check. I'm just going to do a mental check. So plug 2 in. 5 times 2 is 10. 10 plus 2 is 12 over here. 2 plus 10 is 12. So this would be ln 12 equals ln 12, which would work. Okay. So number 4 is good. Number 5, we have only one log. So I have to give you different notes for number 5. Okay, so let me scroll down. So number 5, when you only have one log, like a log on one side of the equation, you're going to isolate the log. You're going to change forms or log on other side 2. And then solve. And again, for these problems, it's important to check. Okay. So you're going to isolate the log. Okay. The log is as isolated as it can get because everything that's inside parentheses is stuck in there. So I'm going to change forms. You're going to go from bacon and eggs to exponential form. So log form to expo form. Remember, expo form is base raised to an exponent equals an answer. So it's 3 raised to the 4 equals 10x minus 9. Now, this is an equation that you can easily solve. 3 to the 4th is 81, 10x minus 9. Add 9 to both sides. So you have 90 is equal to 10x. Divide both sides by 10, and you get x is equal to 9. All right, I'm going to see if I can do a quick mental check. So I have 10 times 9, that's going to be 90. 90 minus 9 is 81. So this would simplify to 81, which would say log base 3 of 81 equals 4. Or in other words, 3 to the 4th equals 81, which is true. Okay, so that does work. All right. And the last problem. Where's my mouse? Okay. So this is a single log as well. So the steps that I was just going through are same here. Isolate the log as much as possible. So if there's like anything outside the log that needed to add to the other side or divide, that's what I'm talking about, isolate the log. The log is completely isolated. So for this one, I'm going to do the same thing. I'm going to go from log form to expo form. All right, so log form is bacon and eggs. Expo form is base raised to an exponent equals an answer. So it's 2 squared equals x squared minus 3x minus 6. So that's 4 equals x squared minus 3x minus 6. Since this is quadratic, I want to set it equal to 0, factor, and solve. So subtract 4 from both sides. So I have x squared minus 3x minus 10 is equal to 0. Now I'm going to try to factor what two numbers multiply to 10 and add to a negative 3. Well, if I have a negative 5 and a positive 2, they will multiply to negative 10. Negative 5 times negative 2 multiplies negative 10, but add to a negative 3. Then I'm going to set them equal to 0. So x minus 5 equals 0. X plus 2 equals 0. So I get two answers. X is equal to 5. X is equal to negative 2. I do need to check, right, and make sure that they both work and that I'm not logging a negative. Okay, so when I check, let's check 5 first. 5 squared, that's 25 minus 15 minus 6. 25 minus 15, 10. 10 minus 6 is 4, right? That would all simplify down to a 4, which is a positive number. And then I can also check log base 2 of 4 equals 2. Or in other words, 2 to the second equals 4. Okay, that works. All right. And then if I'm going to check negative 2, so plugging negative 2 in, negative 2 squared is 4. Negative 3 times negative 2 is a positive 6 minus 6. So 4 plus 6 is 10. 10 minus 6 is 4. So that works as well. You get the same evaluation. Log base 2 of 4 equals 2. Or in other words, 2 squared equals 4. Okay, so they both work. All right. All right, so that, where are you guys? Where did I put you? All right, so that is the end of day 1, lesson 6.6. We'll finish up with day 2 next time we meet. Bye.